Find the limit of a power and the limit of a root. So using the limit of a product, if the limit is x approaches c of f of x squared, you could write it out twice or 5 times or however many, and then you could separate it by multiplication. And you could put the squared completely outside. Same thing as you're able to put the radical completely outside. I'm going to draw your attention to said board. You can read it at your leisure. All right. So, I don't have enough energy for that. I just like putting big old L's. Not loser, it's late. But it's late. All right. So, what we want to do with limits is we always test first. If we put the value in, does it cause us a 0 in the denominator? If it doesn't, we can just put the value in. We can do direct substitution. So, if we put the... Okay. If we put the 2 in, and we have the word limit, what happens to the word limit? It goes away. The moment you distribute in, the limit goes away because it tells us that we put that in there. And 2 to the 5 is 32. The next one we put a 1 in, we get 2 times 1 minus 3 cubed, and we get negative 1 cubed, which is negative 1. So we can enter in the negative 1 up here if we want. So what does that actually mean? The limit as x approaches 1 of 2x minus 3 cubed equals negative 1. What does that mean? What is the limit? From the left and the right, they approach negative 1. So when x equals 1, from the left and the right, this graph approaches negative 1. That's what that means. Now, because it's an actual continuous function, it's a cubic function, we know that at that value it is that too, and we plugged it in and it worked out, right? So if we can do direct substitution and it works out, you know the function is continuous there as well because it exists there. All right. And then this one, we have the limit as x approaches c of x to the n. It says x approaches c, so it's telling you that x goes in for c, n stays in n. So we get c to the n. So what does that mean? That means the limit as x approaches c of the graph x to the n. It's approaching c to the n from the left and the right. So now try problem 15 in your book. Remember, you're still in the same spots, page 100. Do it. You get 1 minute. Same thing here. If you have the cube root of something, you could write the cube root completely outside. Well, why is that? I just said if you had a squared or a cube or like a 3 or a 4 or 5, you could write it outside the whole limit. Do the limit right outside. Well, what is the cube root? Just the same as. Yeah. Power 1/3. So you can still use power rule because it's the same thing, right? So you could write the whole thing outside as a power 1/3, or you could write the whole thing, take the cube root of the entire limit. I always do direct substitution myself and check it out first. So I'm going to plug in the 4. I'm going to get the cube root of 4 squared plus 11, which is the cube root of 27. And what's the cube root of 27? 3. So that limit equals 3. And so what does that mean? That means on the function of cube root of x squared plus 11, as I approach 4 from the left and I approach 4 from the right, my y value is 3. Also, because I could do direct substitution, I know that f of 4 is 3. Right? Just filling it directly in. Okay, here's some more problems. Go. This one as well. We're going to go 8. We're doing this example too. 8 plus 1 to the 3 halves. They don't have to give you a calculator to do this. What does to the 3 halves mean?
Square root it and cube 3 cube. Yeah.
Yes. I get what you're saying. So what you can do is you can take the square root of 9 to the 3, but that's a really large number, correct? Or you can take the square root of 9 and then cube it. So it'd be 3 cubed, which is 27. So work on these 5. That's 5 questions. So here we are, polynomial functions. Limits of polynomials. Polynomials are what kind of functions? Starts with a C. They're continuous functions. If a function is completely continuous everywhere, the limit will be where f of whatever that is, correct? Every time you have a full continuous function, you should be able to plug in your x, get out a y. That's what full continuous functions will do. So for all of these, we can plug in the limit right off the bat. Because so glad that is recorded. All right. I don't think that's fake. This class is something. You sounded like you blew a gasket, like if you were a car or something. All right. Okay, so we have 36 minus 3 plus 2 is 35. So once again, what does that mean? F of 3 is 35, and as I approach the limit from the right and the limit from the left, it's approaching 35, right? It's a continuous function, so from the left and the right and at that value, you're going to have the same value. Okay. Cool, you're going to try 29, but not at this very moment. We're going to try it after. Okay, let's look at 10. If I plug in 1, I'm going to get 4 times 1 squared is 4 plus 5 is 9. Is that okay? Yes, so we can directly substitute. So we're going to get 3 bracket 1 cubed minus 2 times 1 plus 1 over 4 times 1 squared plus 5. And so I'm going to get 3 minus 2 plus 1, which is 4 minus 2, which is 2, over 9. So the limit as x approaches 1. So from the left of 1, from the right of 1, I actually have 2 9s, correct? And at 1, I have 2 9s as well. Okay. Where does this one have asymptotes? Trick question. Asymptotes occur when your denominator equals 0. Where does this have asymptotes?
Denominator and the numerator can't be below 0.
Never. There aren't any asymptotes. Why?
Because the number is squared, so you always end up with either.
You will never end up with a 0, right? No matter what. It's an addition of squares. Addition of squares. You will never end up with any type of 0, because when I would literally need it to be, this 4x squared needs to somehow be equal to negative 5. Then negative 5 plus 5 would be 0, and there would be our issue, right? But anything I plug into x will become out positive. Positive times 4 is a positive. We'll never be able to create a 0, so you don't get any non-permissible values or restrictions, therefore no asymptotes. Okay, this next one, I plug in a 4. Is it going to cause me any problems? No, so I can distribute it in. So I get square root 3, 4 squared plus 1 over 4 minus 1, which is the square root. 16 times 3 is 48 plus 1 is 49 over 3, which is 7 over 3. So is this a continuous function? I just asked, is it a continuous function? No, that would mean the whole thing has to be continuous. Is it a continuous function? No, where's my problem at?
X equals 1.
When x equals 1, I have issues, correct? That would cause an asymptote. It's not going to cancel off. So this graph is not continuous. This function is not continuous. Now if I ask this question, is this function continuous at 4?
Yes.
Yes, I direct substituted in and it worked, correct? So that means from the left as I approach 4 at 7/3, the right as I approach 4 at 7/3, and at 4 at 7/3, because I could directly substitute. So it is continuous at 4, but the function itself is not continuous. I did up top. You're going to try that one after. Now we're going to go to these ones. Yeah. So example 11. If I plug in -2, are we good? No, we have issues. So let's factor it out. We can't direct substitute. For the top, I say, I still write my limit because I'm not substituting in yet. And I say, what multiplies to give me 6 and adds to give me 5?
3 and 2.
3 and 2. So I'm going to get an x plus 3 and an x plus 2. My denominator is the difference of squares. X squared minus 4. What am I going to get?
X minus 2.
X minus 2, x plus 2. Which one of these factors is the problem? Why is x plus 2 the problem? Because when I plug in -2 plus 2 is 0. And 0 times anything is 0. So this x plus 2 is the problem, right? I need to get it to go away. Yeah?
So every time there's a problem like this, it'll be like a really convenient factor on top you can just cancel off.
If it isn't a convenient factor that will cancel off, we're going to have to do L'Hopital's rule, which is later, which we use derivatives. Or they're going to ask you to do it, and it might be in a calculator section, and you do it numerically with a table of values from the left, from the right, and fine.
Oh.
Yeah, but algebraically, we would either have to do it this way or with L'Hopital, which we can't do until we know derivatives. All right. So the issue cancels off. We're happy. Now, if the issue's gone, can I substitute in? What is the issue actually on this graph if those canceled off?
Point discontinuity.
It's a point of discontinuity. So there is a y value from the left and the right that they're approaching that's the same, correct? But we know, is that y value existing though? Does it actually exist on the graph? No, from the left and the right I approach it, but at that value it doesn't exist. So this graph isn't continuous, right? If we can't do direct substitution in for that value, it's not continuous at that value. So now we can plug it in. We go -2 plus 3 over -2 minus 2, and we get 1 over -4. We can go up here and we can say -1/4.
That point doesn't actually exist, but that's what it approaches.
Yeah. So that point does not exist, but the limit is not actually what the value is. The limit is from the left, from the right, it's approaching -1/4. Okay? B, if I plug the 5 in,
Not work.
it does not work because our denominator is 0.
Yeah.
So we know when we have radicals, what do we have to do to try and fix our problem? Conjugate. And we don't care if we're doing it to the numerator or the denominator. There's no rationalizing. We'll do the numerator now, right? So I'm going to multiply the top and the bottom. So I'm going to go equals. Do you see how I have equal signs running down the whole side because the limits all equal each other?
Yeah.
So I have the equals the limit as x approaches 5 of root x minus root 5 over x minus 5. And then we're going to multiply by root x plus root 5. Try that one out and try out. So, when we distribute the top, the conjugates mean that if the reason why you multiply by a conjugate is so that your middle terms go away. So root x is just x. And then we get plus 5 root x, if you want to show the work, minus 5 minus root 5x, not 5 root x, and then minus 5. Because negative root 5 times positive root 5 is negative root 25, which is 5. All over x minus 5, root x plus root 5. Now, I didn't put them together. I don't put the denominator together or the ones that aren't conjugates together because if I put them together, I can't get the x minus 5 to go away, which is my issue. Correct? If that x minus 5 goes away, my life is good. I can plug in. Everything is good. So if I actually FOIL that denominator, I'm embedding the problem in with the other material and I won't be able to cancel it. Right? So we always multiply conjugates when we're doing limits, and the two that aren't conjugates you leave apart. So the top here, maybe we should have a different color. It says I do, but so on the top, I have the limit as x approaches 5 of x minus 5 over x minus 5 root x plus root 5. They cancel off. What's left in the numerator? A 1. And now can I substitute in? Can I substitute? Yes. So when I substitute, what do I not write?
The limb.
The limb part. So I'm going to get 1 over root 5 plus root 5. What's root 5 plus root 5?
2 root 5.
2 root 5. And if you forget, think about it as like, instead of root 5, it's x's. What's x plus x? 2x. So root 5 plus root 5 is 2 root 5s, right? Really got into the space of this one. I'll do that one down here. So I have the limit as x approaches 3 of root x plus 2, or sorry, plus 1 minus 2, over x minus 3. What's the problem in my denominator? This. That's my problem. So I'm trying to get it to cancel off. So once again, I'm going to have to do conjugate. So I'm going to multiply by root x plus 1 plus 2, root x plus 1 plus 2. And so I'm left with the limit. The limit doesn't drop off because I can't substitute it in yet. Root x plus 1 is just x plus 1. And then minus 2 root x plus 1 plus 2 root x plus 1. And they cancel, and they should because it's conjugate. Minus 4. Over, do I distribute my denominators? No. If I distribute my denominators, I'm putting that x minus 3 in somewhere, and it's not going to cancel. So I'm going to get x minus 3, square root x plus 1 plus 2. And then on the top, I get the limit as x approaches 3 of x minus 3 over x minus 3, square root x plus 1 plus 2. These cancel off now. My problem is gone, and then I can do what? Substitute it. So I'm going to get 1 over 3 times square root 3 plus 1 plus 2, which equals 1 over 3 times 4, which equals 1 over 12. So I'm going to give you about 10 minutes to try all the practice problems on this page that I had boxed. Example 13, A and B, I want you guys to try. A is a problem because if I plug a 2 in, I get an issue. But it's not as directly obvious because you have to direct the denominator in this case. And B has an x cubed in the top. So what do you have to remember how to do? Rocket count, synthetic division, be able to find the factors of anything that's higher. Okay? So try it out. So for A, we have to multiply by the conjugate. So we're going to multiply by x plus 2 plus 2, square root of x plus 2 plus 2. And so we're going to get the limit as x approaches 2. The top, are we going to distribute the top? We don't distribute the ones that aren't conjugates. We do distribute the ones that are conjugates. So we're going to get x minus 2, square root x plus 2 plus 2. And then on the denominator, we're going to get x plus 2 minus 2 root x plus 2 plus 2 root x plus 2 minus 4. And then we're going to get the limit as x approaches 2 of x minus 2 square root x plus 2 plus 2 over x minus 2. And then these cancel, and the problem's gone, right? Once the problem's gone, we can substitute in. So we get square root 2 plus 2 plus 2, which is 4. Now, what does that mean? That means there's actually a point of discontinuity at 2, 4, correct? From the left, it's approaching 4. From the right of 2, it's approaching 4. At 4, we have an open dot because they can't stop. All right. The next one, if your calculator is taken away, you would have to do synthetic division, guess, and check with all the factors of 9. Plus or minus 1, plus or minus 3, plus or minus 9. Correct? However, the denominator is a nice quadratic, so I would factor it first, and I would get x plus 3, and I would know that the x plus 3's have to go away, so I would do synthetic division with x equals negative 3. Or for you, Jonah, you would do x equals 3. You do negative? He's a rebel without a cause. That's what he is. All right. So when we factor them out, we would get x plus 3, and something else.
X plus 1.
Yep. And then cancel. And so we get negative 3 plus 1, which is?
3.
Not 3.
It's not 4 either.
Just checking to see if you're paying attention.
Sure.
Who said 4 or who said 3 in the first place?
Me.
At least they didn't say
Well,
4.
I got you on
They were
the game.
closer with the negative.
I shot you, and then
Then did a layup, or did you do like a 3-point garbage?
it's not 3. It's not 4 either.
Well, that was just hard.
All right. I've recorded errors before. It's totally fine.
2105.
Okay. So the next thing, the average rate of change, which is example 12, we're doing tomorrow. But we're going to go over these here, which is Newton's first principle. It's the difference quotient. Shh. We have already done this. The catch is, if I go like this, if I go the limit, as h approaches 0 in front of it, guys, you're finding the derivative. This is the long method of finding the first derivative. So if they ask you for the first derivative right now, this is how you have to do it. If they ask you for the tangent slope right now, that is a fancy way of asking for the first derivative. This is how you would have to do it until the next unit. So your first derivative, tangent slope. Okay? So this one here, we have to use the difference quotient, and then we're supposed to let the limit as h approaches 0. I'm just going to do it all at once. So we're going to do the actual limit. We're going to do this right here. So we're going to do the limit as h approaches 0 of f of x plus h minus f of x all over h. And we've already done this part minus the putting it equal to 0 part, right? So off to the side, we're going to do our x plus h. So I'm going to find f of x plus h off to the side. I don't know why I wrote it so far over. It's going to be squishy. I'm going to get 2x plus h squared minus 3x plus h plus 1. And so I'm going to get 2x squared plus 2xh plus h squared. Because remember, this is the same as writing x plus h twice and FOILing it, correct? Yeah?
What question are we doing? Not 14A, right?
No, we're doing B.
But with the first equation?
It's the same thing. V is just doing this difference quotient with the limit as h approaches 0. So I'm just doing the difference quotient with the limit as h approaches 0. Same question. And then minus 3x minus 3h plus 1. I got sidetracked. Oh. So it's going to be 2x, it's going to be xh, so it's going to be plus 2xh, and I think I said xh wrote 2x. Distribute through, and we're going to get 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1. This is not new to us. We've been practicing this over and over and over, right? So the only difference here is that we have the limit as h approaches 0 in front of it. And I told you we were going to get to that point, but we would have to find the limit as h approaches 0, and that will give us our first derivative or tangent slope. So it's going to equal the limit as h approaches 0. F of x plus h we found off to the side, so it's 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 1, and then I have to subtract all of f of x. So I'm not going to use a bracket, I'm just going to subtract all of f of x, okay? So f of x is 2x squared minus 3x minus 1. When I subtract that, I'm going to get minus 2x squared plus 3x minus 1 all over h. Now I told you h is the problem, and I told you this before we even knew what a limit or make it equal to 0, but I said h is the problem, we're going to have to get rid of h. Well, why is h the problem? Because this formula always uses the limit as h goes to 0. And if I plug in 0, I'm done. I'm doing illegal math. So I told you everything without h's needs to cancel off. 2x squared, negative 2x squared, that has an h minus 3x, h, 1 and 1. Don't know how that happened. 1 and negative 1 cancels. So in the top, I am left with terms with all having h in them, so I can GCF an h out. So I take an h out, I'm left with 4x plus 2h minus 3 all over h. And this is where we would have stopped before, correct? But now we have a limit. Did we get rid of the problem? Yes. So now we can actually substitute in. When we substitute in, we drop off the limit. We don't have to write anymore. So we get 4x plus 2 times 0 minus 3. And so you get 4x minus 3. Now this is the first derivative of 2x squared minus 3x plus 1. It's also the tangent slope of it. It makes no sense to you right now because you have no idea what the first derivative is. Just know that that is what you were finding. So we will learn power rule, which will take about 14 seconds, about 3 seconds to do this. But we still have to be able to do it using the limit law. All right. You guys are going to try this one out. We're bypassing a. I just want you to do the limit as h approaches 0 of f of x plus h minus f of x all over h. We start off where we have the x plus h inserted, squared. Then we make common denominators. When we make common denominators, remember I said don't distribute them. You're just making your life aggressively harder. There's no point because you're going to be plugging in a 0. And so x plus h squared, I have to expand out in the top to x squared plus 2xh plus h squared. Distributed that through. So then I have the limit. I have a common denominator, so I can actually do the math all on the top. So I get x plus h squared, x squared. And I get 3x squared minus 3x squared minus 6xh minus 3h squared. And then times 1 over h. The 3x squareds cancel. I can take an h out of the numerator, because ultimately I'm trying to get this h to cancel. That's the whole goal of the whole time, of all time. So I can take an h out. I'm left with negative 6x minus 3h all over x plus h squared x squared. Times 1 over h. H's cancel off. And I am left with the problem gone, and I can plug in 0, right? So I get negative 6x minus 3 times 0 over x plus 0 squared x squared. So I get negative 6x on the top. Cancels. And then I get x squared times x squared, which is x to the 4. And then we can actually reduce. The h's became zeros, guys. Because the limit is h approaches 0. How else could they write it? Negative 6 x to the negative 3.